Okay, so let's go ahead and start with slide 22 of the Algebra 2 Semester A Unit 2, Divisions with Polynomials, slide 22. So this is the second part. And actually, we're going to talk about the second part of the remainder theorem. So kind of like what we learned is that when in the first part of the remainder theorem, just a little recap, we can take the value of it's a binomial of x plus or minus whatever number. If we take that binomial, set it equal to 0, and solve for x, the value that we get, we can plug into what we are originally trying to divide, our dividend, and the results, and we replace x, substitute x for that value, we're gonna, whatever answer we get is the same answer we get if we actually did long division for that polynomial, and it will give us the same, the remainder. So remember, sometimes you have to be careful. If I ask for the quotient, it means that you're gonna actually have to divide and use long division. In some cases, if I just ask specifically for the remainder, if you had to divide a certain expression, you can save yourself some time by using the remainder theorem. So here are two other key components that I would like for you to make sure you have written down, because they're going to come in handy and you'll probably see them a little bit in the next couple of slides. This setup right here. If P of A, and this is about part 2. So if PA is equal to 0, then x minus a is a factor of the polynomial. So remember, there are two cases where a remainder might be 0 and a remainder is not going to be 0. We like it when it turns out to be 0 because it is turning out to be a factor. So when it's not 0, right, it's 70, or we're left with some type of other expression, we're going to have to actually write that over the divisor. So it just makes our quotient just a little bit not eye-pleasing. Now we look at the second one. If x minus a is a factor of the polynomial p, then p of a is equal to 0. So it's kind of from those two statements right there. The first one, right, is that if we plug it in and we get 0, then it is a factor. And if we're told that x minus a is a factor, then we, by plugging it in, we can also still get that result of 0. So let's go ahead and see how we apply this in the next couple of slides. So here's an example. So P of x equals x cubed plus 7x squared minus 4x minus 28. I know I keep on saying use at least this one right here with that binomial, set it equal to 0, or take the opposite of it. So say, for example, it's x minus 3. Then you're going to say x is equal to 3. Right there, it's because we see like this -3, you take the opposite sign. What happens if it's x plus 5? The value that you're going to use there is x is equal to -5. So that's just a little bit of a shortcut from there. But let's take a look at this one. So P of x, right? It's x cubed plus 7x squared minus 4x minus 28. They factored it by grouping. So remember, with grouping, we set a parentheses in the first two, and then the first two terms and the last two terms, and there's a plus sign in between those two sets of parentheses. In the first set of parentheses, they factored out an x squared. In the second set, they factored out a -4. Now they factored out that x plus 7, and they have x squared minus 4, x plus 7. So the idea is that they're actually breaking down this polynomial for you, P of x. Then x squared minus 4 is the difference of squares. So that's now they didn't tell you what specific equation they were using, but they say rewriting using special products, again, difference of squares. So x squared minus 4 becomes x plus 2, x minus 2. Now, each factor that we have there, they took and they pretty much, how they came up with a is that you take each factor and you set it equal to 0. But again, some math has a lot of patterns. So do you see, I took the first factor, x plus 2, set it equal to 0. Then I'm going to subtract by 2. This cancels. This is going to be x equals -2. So there is my -2 there. Or like I said, here's a shortcut. If it's just x alone in the first term in that set of parentheses, you're going to take the opposite sign of whatever that number's the number behind it. So right there you have a -2. The opposite of a -2 is a +2, which is also listed there. And if you see, they're matching in the same colors. So again, if you're not comfortable with that, jumping into that rule, you set each one equal to 0. Here it's a +7. Your final A is going to be a -7. So we'll be using that little trick to kind of help us out instead of rewriting this every single time. But again, just to double check, take each factor, just set it equal to 0. Let's go ahead and move on to the next slide here. So they took each of these values and they're gonna go back and plug it into the original equation that we had. So they're gonna replace x with -2, solve it. Then they're gonna do it with 2 and then -7. And if we click over here, they did it. There's your remainder of 0. Keep in mind, because we plugged in -2, x plus 2 is considered a factor of that polynomial. They did p of 2, which is verified that that 2 is a factor, or the 2 originates from the factor of p of x. That's why we also get 0. And we get 0 again if we repeat that same thing with the -7. So in other cases, so sometimes a question can come up like, is x plus 5 a factor of this polynomial? Now, you could do long division, long division for the polynomial and take that expression and divide it by x plus 5, or there's a nicer way to do it, right? Take that x plus 5, and I'll write it out on the screen here. If we take x plus 5, I'm going to plug in the value of -5. And if I get 0, it is a factor. X plus 5 will be a factor of that expression or that equation. So let's take a look at this one. Here they have p of x is x to the 4 minus 4x cubed minus 7x squared plus 10x. They're testing out the value x here. So, or x is going to be 1. They're going to plug in 1. Now, keep in mind, 1 comes from x minus 1. 2 is x minus 2. So the idea is that where are these, how do I get these numbers? Remember, it originally they make the statement of p of a. They're calling this x, but it's also that a value that they're plugging in. Now, what about when it's 0? That just means x. And you're going to kind of see, you're going to end up seeing this stuff that I'm writing on the left-hand side right under here. So the question is, why don't we give it a try to verify? Is if I plug in 1, meaning the factor is x minus 1, is it a factor, yes or no? So I have this as 1 to the 4th power, which is 1. So I'm going to just put 1. 1 to the 3rd power is 1. 1 times -4 is -4. 1 squared is 1. 1 times -7, -7. And then we have this plus 10. So 1 minus 4 is -3. -3 and -7 is -10 plus 10. That is 0. We like seeing the 0 there. That means that by plugging in 1, x minus 1 is a factor. See, because again, we got the value of 0. If you plug in 2, meaning it comes from the factor of x minus 2, if we don't get 0, it's going to be a no. So right there, we get -24. So x minus 2 is not a factor. And then we would go ahead and take a look at the other ones. So here, they showed you out the steps for the first two, but again, it's repeating the same thing. P of 0, you do get 0 as well. And that makes sense, right? Because 0 here, 0, 0, and another 0. So all of them are zeros. Because the final answer is a 0, then yes, it is a factor. And then x minus 2. So if you're plugging in the value of -2, that's coming from the factor of x plus 2, which happens to be which you get 0, meaning it is a factor. So again, that is the second part of the remainder theorem here. Okay, so let's go ahead and move on to the next slide right here on slide 24. So it says the table shows the values of function f at a different value at x. Determine which expression of the factor of this polynomial. So what they did for you here is they gave you f of x. So here you don't really have to do some work, you just have to analyze. The idea is for it to be a factor, it has to equal to 0. Again, we are liking the 0 here. So if we identify, so here they plugged in -5 into this equation and they got a 0 there. We like it. So I'm going to go ahead and highlight it here. Where else do we have a 0? You want to take a look at that. It looks like we have right here and another one right here. The question is, what is the factor? So I'm going to give you one factor right here. If you had -5 here, remember, as you go backwards, take the opposite sign. So here, -5 comes from the factor of x plus 5. And I'll go ahead and let you select the other ones, the other two right there for the -3 and 4. Again, you go reverse by taking the opposite sign and including it with your x there. Moving on to slide 25. So we're going to go ahead and talk about synthetic division. Now, synthetic division is going to be using a combination of the idea from remainder theorem. We're still going to divide, but instead of using long division, we're going to use synthetic division. And the idea is that we only focus on the coefficients, and we can do a side-by-side comparison. So for synthetic division, if you remember, we had something very, very similar to this here. P of x is your dividend. X minus a is your divisor. Now, synthetic division only works if you're going to take your dividend and or your divisor is set up like this format. It's x minus a number, x plus a number. Then you'll find your quotient. The same rule applies. If you have no remainder, that means it's 0, right? Or this idea is coming from the remainder theorem. If you do have a remainder, then P of a does not equal 0. X minus a and the quotient are factors. X minus a and quotients are not factors. Why do we tend to like synthetic division? I will show you a little bit why. So it looks like in this video, they're going to go ahead and give us an example, which you can go over, or let me see. Okay. You can go ahead and review this video. I'm going to go ahead and move on to another, take a moment to pause my video, go ahead and play this video and watch how they do synthetic division. I'm going to go ahead and apply the same thing. My setup is going to look a little bit different, but it is going to be very similar. So let me go ahead and look at this one here. So using synthetic division to factor. The idea with synthetic division is that you are using, it is an idea from long division. It is more of a shortcut, and you're trying to break down the polynomial as much as you can. So remember how I said when we're dealing with polynomials, we know how to deal with it. It has 2 terms, 3 terms, 4 terms. But sometimes we can't really see with 4 terms, right? So the idea, or maybe it's not, yeah, when we have 4 terms, like for this example here on slide 28, maybe we don't have, what is it called? Maybe it's not crystal clear for us how to factor this. So what we're going to go ahead and do is we're going to use these examples. They're saying that, let me go ahead and read this. So earlier we found 3 of its factors, but since a polynomial has a degree of 4, it should have 1 more factor. So remember the idea, whatever the highest degree power it is, that's how many answers I should have. So it does say it's x to the 4th power. That 4 tells me I should have 4 answers or 4 factors. We are given 3 factors right here. I'm going to use synthetic division to help us find out that last factor. And I think that's what they're also going to go ahead and do here. So we can factor this. Do I want to, but I'm going to go ahead and apply the synthetic division, which you should have saw in that video on slide 27. So let me go ahead and do my work over here. So remember the values that I get. So by using zero, or I mean, by using X, it is going to, we're going to plug in the value 0. By using X minus 1, or from the factor of X minus 1, we're going to use positive 1. From X plus 2, we are going to use negative 2. Now, I don't want to use a remainder theorem and plug these in to get the actual remainder. Remember, we're not trying to find the remainder here. We're trying to find the factors. And we're going to wrap it around how synthetic division helps us with that. So what I'm going to do is write out the coefficients for this here. So they put a little box and they write out the coefficients. So in this case here, I have a coefficient here of 1. And then it's x to the 4th, x to the 3rd, so that is negative 4. Negative x to the 3rd, x squared, so that is negative 7. X squared, then I should have x, which is for 10. And then after 10x, I should have a constant. I'm just going to place a 0 there. So what we're going to do here is, let's try, I think in the example here, they're going to actually try with the 0 first. Or actually, they're going to try with 1. We can do 1. I just don't want to copy what they did because I want to make sure we get the synthetic division here. So let's try 0. And so that's coming from that first factor. I'm going to put 0 here. Now the first, do you notice that we wrote out only the coefficients for each of those terms. And remember that idea about adding a placement in case we don't have a degree there, we need to put a placement of a 0 and then x to whatever power, or in this case here, this one didn't necessarily need to have an x. It was our constant was missing, so we fill it in as a 0. It's like a fluff as a placeholder there for us. So the first number here, you're going to go ahead and drop down. So this is our 1. And anything below this line gets multiplied to up here, to this little box here. So it's 1 times 0, which is 0. Negative 4 plus 0 is negative 4. Negative 4 times 0 is 0. Negative 7 plus 0 is negative 7. So the idea between these two numbers here is that you're adding them straight and from up and down. Negative 7 times 0 is 0. 10 plus 0 is 10. 10 times 0 is 0. 0 plus 0 is 0. So we just completed synthetic division on this. Now, again, they didn't use 0 because in here they already factored out an x, but I already used this option here. Now, originally we started out with x to the 4th power. With synthetic division, if we get this over here to be 0, meaning that this is a factor, this will be our new polynomial already broken down, but with 1 power less. So we originally started with, this was x to the 4th power. This is now going to be x to the 3rd power, x squared, x plus our constant here. So then let's rewrite this over here. So I'm not going to use this one anymore. I'm going to use the 1. Or actually, let's try negative 2 instead. So let's put negative 2 here on our outside box. And we're messing with the factor of x plus 2. So I'm going to write out the coefficients for this one right here that we got in this here. So it's going to be 1, negative 4, negative 7, and 10. I draw my line here. This first one comes down, so that's 1. Remember, anything below this line, this is going to be added. Down here is multiplied to this top right here. 1 times -2 is -2. -4 plus -2 is -6. -6 times -2 is +12. Then -7 plus 12 is going to be 5. Oops. So 5 times -2 is -10. 10 minus 10 or 10 plus -10 is 0. Again, this started out from x to the third power. So I already used this factor. Now this started originally from x to the third power. Now this is one less, x to the 2 power. This is x and then plus our constant 5. Now from already there, we can use our giant x that we learned from factoring polynomials to go ahead and find the break the factor down even more. Or because we're given that last factor of x minus 1, we can use 1 for synthetic division, which I'll make a line right here and use these values as well. So you can use the giant x for 1x squared minus 6x plus 5, or we can use synthetic division using this one right here. So it'd be 1, and the values is going to be 1, -6, and then 5. Keep in mind, do you see how we're this is the one where we started with for p of x. It's 1, 2, 3, 4, 5 terms that I listed. Then we went down to 1, 2, 3, 4 terms. We wrote out our 4 terms right here. Now we're down to 3 terms. Synthetic division helps us to get to break down that polynomial as much as we can. But the idea is that very last number, the one that I've always boxed over here on the right-hand side, must be 0. If it is not 0, it is not a factor. So then let's go ahead and continue with this for synthetic division. We bring down this value here, 1. Remember, up at the top, they're adding. 1 times 1 is 1. -6 plus 1 is -5. -5 times 1 is also -5. 5 minus 5, we get 0. And remember, this originated from x squared. So then 1 power less than that is x minus 5. So did you notice we already used this one? Now we have this last factor, x minus 5, which if you plug in 5 into the original formula over here, you're going to get a result of 0 as well. So here are our factors for p of x. And if you click on it through there, they did something similar. The reason why I took this approach and I use only synthetic division is just that we can get comfortable, because I know we just watched you just watched the video of how to perform synthetic division. Again, sometimes with the math, it's not always about practice, or it's not just about picking up the concept right at that moment. It is more about how do I put this? It is more about practicing it here. Okay. So by looking at this on slide 29, it says, what is the factored form of this polynomial? So they want us to factor it. I see 4 terms. I can try to break it apart. Actually, we can try to break it apart. So again, we see 4 terms, we are left with grouping. So if I group the first 2 terms, so that is x cubed plus 7x squared, and plus parentheses, we group the last 2 terms, 4x minus 12. We're trying to find the factors. You can kind of use that. No, you don't want to use that. Just let's go ahead and jump into this. So if we take a look at the first 2 terms, what we can factor out in x squared. So then we're left with x plus 7 plus, here we factor out a 4, it's x minus 3. We ran into a little hiccup there. Normally when I group in the red line, those parentheses need to be matching. They're not matching. I have two different sets here. So we're stuck a little bit here in a sense of factoring or by grouping is not going to work for this. So we can look at the worked example and see what they used. I'm pretty sure we're gonna use synthetic division. The thing is, we need to figure out what value to plug in, and it looks like they played around with values here. So what we're gonna do is we're gonna do the same. All we need to do is find one. So let's take a look of our list here. You have a set of answers here. Now, again, I'm gonna take the approach of the synthetic division way, only because we want to make sure we practice it that enough to understand it, because that does come in super helpful when instead of doing long polynomial division. So I'm gonna write out all the factors here. It's x plus 1, and we're using 3 as well. Okay, so we're gonna use x plus 1. Again, we're only going to do one, and then I'll have you continue doing on the rest. But we just need to find one number. And hopefully that will help us figure it out. Now, remember the numbers that we come up with. So because I have plus 1 here, the value we're plugging in is -1. Since I have x minus 1, it is positive 1. Since it's x plus 3, we're using -3. And x minus 3, we're using positive 3. So these are the values that we're going to test out using synthetic division. I know I wrote it out like kind of what I saw in the video, but we can also draw it out like this, like a division sign, where I'm going to put my -1 here on the outside. And in the inside, it's like very similar to how we would set up long division. But remember, we're only writing the coefficients here. So I'm going to write my dividend inside. So instead of x cubed, right, it's just going to be the coefficient for that. So it's 1. After x cubed, I remember it should go in descending order. X squared, we have 7. So we'll go ahead and put 7 here. Then it's x. So we'll put our 4 and then our -12. So this is just to test. The idea is that last value has to be 0. If we got 0, we have a factor. We have one of our answers. If it doesn't, then we need to go ahead and try another one. So let me draw my line. And remember, these are being added in between these two. You always bring down the first term, so 1. 1 times -1 is -1. 7 minus 1 is 6. 6 times -1 is -6. 4 plus -6 is -2. 7 minus 1, -1, 7 minutes, okay, -6. -2 times -1 is +2. -12 plus 2 is -10. I always end up boxing this last number because that's the one I want to check for. I do not have 0 there, meaning this does not work. This is not a factor for p of x. So we try it again. So what I'm going to do is I'm going to erase it because we're going to try out 1. But do you see how I only have to erase this part here? I didn't have to erase that one. And we try it again. So we're using +1 here in this case. So I bring down this 1. 1 times 1 is 1. 7 plus 1 is 8. 8 times 1 is 8. 4 plus 8 is 12. 12 times 1 is 12. -12 plus 12 is 0. I just found my factor. It is x minus 1. So we found one of them already. Now you can go ahead and repeat the same thing as for these two. You can write out your factors right here, know the values, and use synthetic division. Now, this is one thing I want you to be careful with, is that here we started out with x cubed. Remember that rule, that lovely rule of ours, that if this starts out with x cubed, this is going to be 1 power less. We have now x squared plus 8x plus 12. You can now use this one and set up your synthetic division and then apply it to these factors here. So I'll go ahead and write out the setup. Your value is going to go on the outside here, and the coefficients are going to be 1, 8, and 12. Remember that last value here has to be a 0. If it is not a 0, you move on to the next one until you get 0, you'll find your factor. Or another hint is use a giant X to go ahead and factor that there. So I'll go ahead and take a moment to do that for slide 29. So moving on to slide 30, using synthetic division to identify factors. So the remainder theorem states that if we evaluate the polynomial for a specific value, a, then the result is 0. Then x minus a is a linear factor for the polynomial. We can also use synthetic division to evaluate polynomials and identify factors. Consider the polynomial p of x for 3x to the third minus 19x squared plus 22x plus 24. Use synthetic division to determine whether each of these expressions is a factor of p. When you're ready, select the expression to check your answer. So how do we know if these are factors? There's two ways to do it, and I'm going to test out the two different ways to test this out. I'm going to use the two right here, but I'm going to do it two separate ways. Remember, for remainder theorem, if I have my x minus 4 here, I know x is equal to 4. Remember that little trick of taking the opposite sign? Now this 4 is valuable to us because we use this 4 for synthetic division, or the remainder theorem, the part 1, which we found out that if I plug in the value 4 into the original equation, whatever value I get, right, to prove that it's a factor, we have to get 0. So let's go ahead and try it. So I'm going to try the remainder theorem, the first part. So I will be putting in p of 4 is equal to 3 parentheses 4 to the third power minus 19 times 4 to the 2 power, 2 power, plus 22 times 4 plus 24. So 4 to the third power is 4 squared is 16. 16 times 4 is 64. Times that by 3, we get 192. And again, you can go ahead and use a scientific calculator to help you out. Then we have 4 squared, which is 16, times that negative 19. We get negative 304. 22 times 4 is 88. And then we have this plus 24. So if we apply this, right, 192 minus 304 plus 88 plus 24, we get 0. This means x minus 4 is a factor. So it says, it is telling us below, use synthetic division to determine whether these expression is a factor of p. It did say use synthetic division, but we can use the first part of remainder theorem, right? Plug in that value and get 0. If I were to do synthetic division for this same one as well, we're going to get also the result of 0. And we're going to get a p of x just a bit broken down because we know it's true. So again, I know I said I was going to do it two separate ones, but we'll just do it with the same one to prove it. And then you can go ahead and do the other two on your own as practice. So again, we're using that 4 value. So I'll bring it up over here at the top. And I'm going to write all my coefficients for the dividend here. So we're starting with the highest power, which is with x cubed. So the coefficient for x cubed is 3. After x cubed should be x squared, and the coefficient for x squared is negative 19. So we'll have negative 19 here. The coefficient after x squared should be x, which is for 22. And then we should have a constant 24. So we bring down this value first, 3. And remember, up here gets added, and then we multiply up here. So 3 times 4 is 12. 19, negative 19 plus 12 is negative 7. Negative 7 times 4 is negative 28. 22 minus or plus negative 28 is negative 6. Negative 6 times 4 is negative 24. 24 minus 24, we get 0. So it is a factor because, again, we end up with 0. So if you think about it, I can rewrite p of x with, I already know x minus 4 is a factor. I can write this out as x minus 4, parentheses 3. Remember, originally we started with x cubed. This is now going to be 3x squared minus 7x minus 6. That last number, again, determines if we do have a factor or not, and it's not used when we're writing out these answers here. So go ahead and try both ways of using, by plugging in the value into the equation or using synthetic division for x plus 2 and x minus 3. So let's go ahead and take a look at this one right here on slide 31. So it says use synthetic division to find all the possible factors for this polynomial. Okay, so we can test it out, right? Where they gave us some certain factors. We can test it out by setting up our synthetic division. Now remember, you don't want to use the same polynomial over and over again because, again, here we have 2, 4, 5 terms to look at. Once you find one factor where you get a 0, take that new equation there. So let's try out x minus 1 first, right? So for x minus 1, we're going to use the value 1, positive 1. So let's set up our synthetic division over here. Let me make some more space so we can kind of see it all there. So I'm going to help you test it out with 1 until we find one factor at least, and then you'll go ahead and continue on the rest. So I'm going to use this 1 here, and I'm going to set this up. So keep in mind, we're starting it with x to the 4th. The coefficient for that one is 1. Then it's 1 less power, so x to the 3rd, the coefficient there is 4. X squared, the coefficient there is negative 7. X, the coefficient there is negative 22. I gotta make this longer. Then it's just 24. So I'm gonna draw my line, and I'm gonna bring down my first term right there, 1. So 1 times 1 is 1. 4 plus 1 is 5. 5 times 1 is 5. Negative 7 plus 5 is negative 2. Negative 2 times 1 is negative 2. Negative 22 plus negative 2 is negative 24. Negative 4 times 1 is negative 24. And right there we get 0. So we did find a factor. It is x minus 1 is a factor. Because, again, that very last number is a 0. Now, you can continue using these factors and apply it to here. All you got to do is clean this up and just replace this one value with whatever next value you have is next. But instead of doing all that, give yourselves a little bit more or less work to do here. Trying to bring everything back. Okay. So again, this what we have inside written started originally with x to the 4th power. This answer here is going to be 1 less power. So this is x to the 3rd power. This is x squared. This is x, and then your constant. So now you can rewrite your new synthetic division where, again, you're going to put your number out here. And I'm going to write the coefficients here. So for the new set, 1, 5, -2, -24. And then just repeat the same steps. So again, you don't want to be using x minus 1 anymore because that already worked. You'll go ahead and move on to the next one. So again, if you take x plus 2, you're going to be plugging in the value -2. So you'll try out -2 here. Do your setup for synthetic division. Don't forget to bring down your 1. And you are going to continue breaking it down. Keep in mind, I already gave you 1, which is x minus 1. Because this is raised to the power of 4, you have 3 more to look for. So go ahead and get that practice in using synthetic division to go ahead and determine what are the other 3 factors there. So let me go ahead and continue moving on. So we've already reached the end of the tutorial. Again, we learned a long division, and then we also learned about synthetic division, and they actually give you a side-by-side comparison. So here, they did give you the problem setup, and they did use long division here. Now, it's the same setup as if they did it for synthetic division, but remember, it has to be the divisor has to be x plus or minus a number. Whatever that number is, you take the opposite and plug it in. Now, keep in mind when they're asking you for about the remainder theorem, if they say x plus 2 is this a factor? Well, you know that x is going to be equal to -2, and if you use synthetic division, you get 0. It is a factor. Or take that -2, plug it into the equation. If you get 0, you also have a factor. Remember, we like the zeros. And it looks like they do provide another video using Khan Academy. Definitely check it out there. You have more examples there to look at. Again, sometimes it doesn't hurt following along and seeing those examples, because again, with math, it's all about the practice. And then here, slide 34, again, it's a little bit about the remainder theorem. So if we plug in the value of 1 into this equation and we get 0, then that means x minus 1 is a factor. And you'll go ahead and say yes. If we do not get 0, then it's considered not a factor. The more we get zeros, the more we can break down this polynomial and find its factors and have it completely factored for us. Remember, if they plug in the value 0, it is going to be just x. So be very, very careful with that. And that is the end of the divisions with polynomials tutorial.